Hey guys, welcome back to the channel and to the next program, lead code 134 gas station. Let's see what the problem statement offers us. There are n gas stations along a circular route. Okay, the route is a circular one, and we have n number of gas stations where the amount of gas at the ith station is gas of 5. Okay, each element in the gas array represents the amount of gas at that station. You have a car with an unlimited gas tank and it costs, okay, cost of oil of gas to travel from, okay, this is the cost in metrics of gas to travel from ith station to its next type plus one station. So we can move from one station to another station one by one, and it cost of I for one move. Initially will be at any gas at one of the gas stations. So that is at any of the gas stations. We might start from any of the gas stations, and we can move one step, I mean from one gas station to another gas station one by one. And for moving, it will cost the amount of gas provided in the cost. Given two integer arrays gas and cost, return the starting gas station index if you can travel around the circuit once. Okay, in the clockwise direction. So we have to move in the clockwise direction, and we have to return a index at which we can make a one complete cycle, or else we should return -1 if we couldn't make a circle starting from at any position. Okay, so let's think of an approach. What could we do? We can start, like we can try starting from in every gas station and see if it ends up at the same position, which would take uh, order of n square time. Let's see the constants. N will be between 1 and 10 to the power of 5. So n square is ruled out. We have to do it in order of n time. Please generate that the answer is unique. Okay. So starting from 1. Oh, one second, guys. Well, let's see what we have to do. 1, 2, 3, 4, 5. 1, 2, 2, 2, 2, 3, 4, 5. Let's see. If we start from the 1, we'll add 1 to the tank. Now we have 1 in the tank, and we have to move to the next one, which would add 2 to the tank. Now we'll have 3, but we have to remove 3 gas points, which would make our tank 0 again, and we cannot move forward. So it's ruled out. We start from 2, we go to the 3, which would make 5, but -4 to move from 2 to 3. So tank is 1. And if we move to the next position, we'll have +4 -5, which would make 0. So it is ruled out. What if we do the cumulative addition? 1, 3, 6, 10, and 15. So if I start from 1, so if from here, if we start at 2, we'll have 2 in our tank. Moving forward, we'll make 2 plus 3 in our tank, 5, but moving will cost 3. So we have 2 in our tank, and we'll move to 3 to 4. With our tank is filled with 2, and +4 will 6. -4 will do will leave 2. And if you move from 4 to 2 again, we'll do +2 -3. Let's see. You can't start at station 0 or 1 as there is not enough gas to travel to the next station. If you start at 2, okay, you got it, guys. You cannot move forward. So we'll do 2 -3, then +3. If we start at 3, 3 -4 will be -1. So we should exclude it. And from 4, okay, let's from 1, 1 -3 will give -2, so we'll avoid it. From 2, 2 -4 will do -2, 3 -12 -2, 4. Got it, guys. So let's go. So current tank equals to 0. of 0 for I n equals to length of current time will be 0. Will range of n j plus 1% n Let's see how this will go. Well, seems like it is working fine. But I'm not sure. Order of n square, huh? If you are doing this, we are not taking a greedy approach here, literally. Greedy is selecting a position that would give a leverage. So we are selecting 0, 1, 2, 3, 4. 1, 2, 3, 4. Okay. At 4, current tank is filled with 4. 8, 7, 6. Okay. 6 is 7 minus 3 plus 2. 3. 7 minus 3 would be 7 is obviously greater than 3. So X is greater than 4. 5 current tank minus cost of J. 340 1 3 4 0 1. Eight 7 6 5. Travel to station 3. Travel to station 3. The cost is 5. Your gas is just enough to travel up to the station 3. Well, it is working fine. Let's try submitting it. What can it handle order of, I mean, 10 to the power of 5? And that's what I thought, but the solution is at least right. Like it take order of and time to search all of these. Okay, I don't know whether this will be good or not. Let's ask ChatGPT. We made a solution with order of n square time complexity. Can it optimize it? How would greedy helpful here? Do we need to sit for it? Your turn over 45 square. The trick is you never need to restart from every station. If a station fails, you can skip a large chunk safely. The trick is you never need to restart from every station. Okay. I think it's a DP based problem. You want to find a start index. I fetch that. Okay, current approach. Okay. If the total amount of gas is less than the total cost, no solution. Suppose you start at index 0 and move forward. Current net gas while moving. Maintain total equals to net sum of if at some point current tank becomes negative, that means none of the stations before or at this position can be a valid start because they all fail to even reach the next one. Okay, so for example, 1 minus 3 minus 1, 2 minus 4, 3 minus 5. 3 minus 5 will be minus 3 minus 5 will be minus 2. 4 minus 1 will be 5 and 5 minus 2 will be 3. So so since the first fetch from the behind, if set the next station as your next candidate start. If total is greater than equal to 0, the last recorded start is the valid one. So total current and start. Total plus difference. If the current time greater than 0, less than 0, start at I plus 1th position. If current is less than 0, you start from I plus 1th position. So to put it simply, if starting at the position that before any point where the cumulative travel cost calculation the cumulative starting at a position before a point where the cumulative travel cost. Let's try this one now. So for a range of length of gas. Before that, current gas total and start position equals to 0, 0 and 0 respectively. So it is said that we are starting at 0th position, which is the starting position. Now current plus, gas plus equals to I think total is not this. Current gas is less than 0. Current gas and if total is greater than or equals to 0. Let it be. Nah, let's keep it as a difference. If total is greater than or equal to 0, else return -1. Let's submit this. Let's see what others did. 37 milliseconds. Oh, that's a intelligent solution. Actually, this should be the better answer. Anyway, both of them would take order of n time only. So to explain the intuition, we are having the current gas and the total gas cost and starting position. We are initially starting at 0 position and our current initial gas is 0. So total would obviously 0. While we are going forward, we are calculating the difference and we are adding up the difference to the current gas and total. But if at any position, if the current gas becomes deficit or low, below 0, we cannot go any further. So we reinitializing current gas to 0 and starting at I plus 1th position because we already checked until ith position, and any point before I would be a not valid solution because if we face a deficit at certain position, even though we had the accumulation of all the previous gas stations, we will sure to encounter the deficit again if we start anywhere before that deficit point. So we are rather starting after the deficit point and seeing if there exists any such position. And finally, we are checking if the total is total gas. If we have any gas left in our tank or we have 0 gas left in our tank, we made we made our journey to the destination without losing the complete gas or with the enough gas. If the total is negative, then that means there won't be any position where you will start and won't end up becoming bankrupt because you used all the gas you could get and still the cost of travel is much more than the gas you have. So we'll return -1. So that's it, guys. If you like the video, upvote it and share it with your friends. And don't forget to subscribe to the channel. We'll meet you again with another video. Until then, keep learning, keep pushing hard, and keep learning. And don't forget to leave a comment so that we'll get a better reach and I can address your problems as well. Thank you, guys. Goodbye.